Water pours into a cylindrical tank of diameter 4 meters at a constant rate of 1 kiloliter per hour. By how much does the water level rise in 5 hours? It wants us to give the answer to the nearest millimeter. Note that it doesn't actually say give your answer in millimeters, it just says to the nearest millimeter, so this is about rounding. I think I'll probably start with the cylindrical tank of diameter 4. With a question like this, it's so much easier if you have a picture, so let's just draw a little picture. So cylindrical means it's a cylinder, so something like that. Diameter is 4, so all the way across there is 4 meters, and it's 3D something, oh dear, something that's better, something like that, right? So you've got your cylindrical tank, there we can see inside it, and you've got some kind of water level, so up to some level. It doesn't necessarily need to start empty, it might do, it might not, but the point is you are pouring new water in, so it's probably being poured in the top. When that happens, this height h is going up, so once we put more water in, the height goes up, and it's telling us that 1 kiloliter of water per hour is going up. So this is in meters here, so we're going to have to find a volume or a volume expression, and then we're going to have to probably turn these kiloliters into cubic meters, so I might start there actually. So remember that 1 kiloliter equals 1,000 liters. Okay, so this must mean that we've got 1,000 liters per hour, but you should also know, so that should say 1,000, you should also know that 1 meters cubed is 1,000 liters. So this means that we've got 1 cubic meter per hour. So 1 meters cubed of water, so that much water in 1 hour. So how much water in 5 hours? Well, that's going to be 1 times 5. So in 5 hours, you're going to have 5 cubic meters, right? So that's the first bit. We now know we have a volume to work with, and it's going to be the same units as what we've got here. So if we just deal with the radius, so hopefully you either know or you can find in your formula book that the volume of a cylinder is pi r squared h, right? So we have r, h is the thing that we're not sure about. So by how much does the water level rise? How much does it rise? That is our h, isn't it? It's supposed to be an arrow. So how much does the water level rise? That is the h that we don't know yet. So volume equals pi r squared h. So let's put in as many of those as we can. So equals pi times 2 squared times h. Well, we don't know h, but we do know 2 squared. It's definitely not beneficial at this stage to turn the pi into a decimal. It just doesn't help you in any way. So this is pi times 4 times h, so we're going to call that 4 pi h. Right, so that's the volume of water at any given time for a particular height. So if we've been asked what would the height go up in 5 hours, so we know that the volume goes up by 5 cubic meters in 5 hours. So basically the volume change, as this is our expression for volume, 4 pi h must be equal to 5. So 4 pi h, as in the expression for volume, equals the amount of volume that this changes by, equals 5. So we need to find h. Well, h must be equal to 5 divided by the 4 pi. 5 divided by 4 pi is definitely a calculator question. That equals, just using your calculator, 0.397887, and that will do. And then we've been asked for the number to the nearest millimeter, so if you think this is meters, so meters, So the next digit must be, I suppose, deci. Well, there's 10 of these, so that must be sort of decimeters. Then this must be centimeters. So the thousandths must be millimeters because there's 1,000 millimeters. So this is the digit we're interested in, the 7. You look next door, it's an 8. The 8 will make this 7 round up. So the final answer is 0.398 meters. I'm sure you could give that in millimeters. It doesn't say not to. You could say, well, it's 398 millimeters to the nearest millimeter. That's fine. But this is also fine. So this water is going to raise, or the height is going to rise by 0.398 meters in 5 hours if 1 kiloliter per hour of water is being poured into that tank with radius 2 meters.